Create a set of data with this function, graph this data set, and what kind of transformation should be done to make this data more linear. Well, already we could see from this that this is an example of y equals ax to the b power, right? So that's a case where we're going to need to do a log-log transformation. We're going to need to do transformations to both x and y. But let's first look at the shape of it to see what this data looks like. Okay. So if you download the examples, let's put in, it has, for example 1, I've already put in the function y equals ax to the power b. Let's put in a, which is 10, and b, negative 0.4. 10 and negative 0.4. Now, I've already seeded this with just a whole bunch of positive integers for x that are just steadily going up, all the way up to 33. So now let's find the corresponding y values. So in order to find y, we just have to follow this formula up here. So y equals a times x to the power b. And remember, Excel knows order of operations, so it should do the power before it does the multiplication. And once we have that, I'm just going to drag all this all the way down and get a whole set of data. Oh, I think I forgot to lock down, yes I did. So I forgot to lock down A and B, so that's why it's giving me all this craziness. So let's lock down A and lock down B. So once we have that, then I can. All right. And now we see we have this nice curve. If you remember, this is sort of like the second type of curve or so. So we know we need to do both kinds of transformations already, right? And it would be helpful for us if we could actually sort of shrink y, but also maybe shrink x. And log is a way of shrinking, both of them. And so why don't we try log? So let's do log transform. So get log of x and get log of y. Feel free to also use natural log. I'm going to assume log base 10. And Excel thankfully has log, and I'm going to use log 10. And I'm going to put in my x, right? And so it's going to change x from this into the sort of exponent. So 10 to the 0 power will give us 1, right? And I'm going to do the same thing to y. Oops. Okay, so 10 to the first power, 1, to the power 1 will give us 10. Right? And so I'm going to take that and copy and paste that all the way down and get a nice log transform. And here I've already put this graph and set this up so that it'll actually get this data. So if you click on those, it'll show you which data that it's using. And I've already labeled it as log y instead of just y, and log x instead of just x. And what do you notice? This data that has once been curved is now sort of straightened out, right? And so this is one way where transformations can be useful, because now we could use log x and y instead of x and y and put log x and y into our regression calculations and into our correlation calculations, and we should be able to get more traction out of using those tools.